Hello, everyone, and my name is Wei Wang. I'm a PhD student from Politecnico di Milano. I'm very happy to be here today and present our work exploring eco-design strategies for E-Textiles in sports performance applications. So E-Textiles offer refers to textiles that integrated with the circuit, sensors, and electronics to react to environmental stimuli. And its market grows very fast during recent years and is expected to increase even more for future 10 years. Based on the research from model intelligence among all applications, the sportive e-textile gains most acceptance and has the potential to dominate the future e-textile mass market. However, these quick growth also leads to the sustainable issues. The e-textiles combine the textiles and the electronics. It's difficult to be recycled due to three types of reasons. These are the normative and feasible recycling classifications, difficulties of disassembled microelectronics and materials, and the lack of responsibilities among different players in the supply chain. So as a designer, we are wondering if these issues can be addressed from the design perspective. That's why we conduct this research focused on eco-design strategies for e-textiles, looking from the four main phases of the fashion supply chain and value chain. We are design phase, manufacturing phase, use phase, and the end of life phase. So this study is based on a literature review. We searched from different data libraries using limited keywords. In the end, we selected a total of 18 studies that contributed to this theme. And here are the results. So we divided all the studies into four phases, as I mentioned before, and summarized the findings into 8 eco-design strategies. As you can see in the first page of the frame, the first 4 eco-design strategies focus on design and end-of-life phases. And then the others are more focused on the manufacturing and use phases. Among all, we see the design phase is the most important to promote the eco-design of e-textiles, and it can prevent the waste in the early stage. So start from the first eco-design strategy is the design for modularity. It means to design various modular constructions for easy removal or replacement. So the picture showed a simple example is called Rewear. That is an e-textile kit with 12 different modules that can be attached and detached through adhesive tape. Then the design for disassembly is also a smart solution. It keeps the electronics and fabric separate and prove an easy way to disassemble them. As shown in this picture, the designer used disassembling stitches to undo the conductive thread. This method can 100% recycle all the materials and without any damages. Then the design for recycling focused on creating a closed loop for material recovery. That means that the e-textiles can be recycled and reused over the time. In a smart shirt project that developed by Wei Wang in 2018, they used the printed sensor that can be reassembled through the lamination process and reused or replaced. To address to e-textile longevity, it is important to think about its durability and washability, as the circuitry and electronics might be easily damaged during the wearing and washing. A GPU adhesive is applied to protect the circuit by heat and press. Some studies already found it as a feasible way, and a lot of the smart clothes are already using it in their design. Except these, we can also think to design a customized care and repair label for the e-textile to teach customers to prolong its lifespan. About the circularity, a study in 2023 proposed the 4R paradigm. It suggested to reduce the material emission and waste during manufacturing, replace materials with biomass, recycle the textiles and e-components and allow to repair and part of the e-textile when it's necessary. One effective way to reduce the waste is adopting 3D printing technology. We're already quite familiar with this functionality, and a recent study found the possibility to 3D print the conductive fibers and even the stretchable fabrics. In the use space, there is an urgent need to replace the anchor battery with a clean energy supply. Self-power generation technology is seen as a future direction of it. Some inspirational technologies such as the triboelectric now generators and flexible thermoelectric generations appeared in the laboratory stage. And among these, the flexible sensor solar cell is seen as an economic solution. Designer POLIMI Milan wants to install and create various fashion garments and textiles that integrated with the solar panels to generate power for the garment. Last, but it's not the least, the design for low impact. Here we refer to substitute with less eco-impact materials or textiles. For example, biodegradable electronic materials. A study from Kwon developed a degradable printed circuit that can be separated in warm water and recycled. Lastly, in the discussion part, we want to highlight some current initiations of these eco-design strategies. First, the lack of recycling solutions in the industry, and people are not aware enough of the e-textile popularity among different stakeholders. That some of the eco-design strategies are still in a prototype or laboratory stage. Use a manual assembly way to recycle the materials, and there is still a long way to go for those scalability. Last, there is a knowledge gap between technicians and designers in the e-textile field, and the lack of relevant literatures that focus on the design for the e-textile disassembly. To address to this issue, the interdisciplinary collaboration are important. We need to create an interdisciplinary team that includes designers, engineers, and business experts to develop the sustainable e-textile that ensures aesthetic, durability, functionality, and economic feasibility. The future step of our study will continue work on the wider research from a holistic perspective, including stakeholders, and it conduct experimental research from a design perspective. Thank you for your attention.